Here we are, 10Cs, the end of linear functions. Last lesson. Last lesson is going to talk about the general form of an equation for a line. Now, quick review. We had the slope-intercept form of an equation. This is the probably most essential one to know. Being able to isolate the y so you can get slope and y-intercept. Easy to work with. This is the most important form. Putting any equation into this form gives you great information. The second one we looked at was slope points, point-slope form. And the difference is we don't always have a slope, or a y-intercept to deal with. Sometimes it's just another point. That's why y minus y1 equals slope times x minus x1, where we deal with the slope, but the y1 and x1 give us a point on the line. Well, the last situation is the general form of an equation. The general form of equation, in all honesty, really does nothing for us in terms of a line specifically. However, it's the general form of any equation. And moving forward, you will see in math this equation pop up for other situations other than lines. So having a general form, understanding the general form is important to know. But what does the general form tell us in terms of a line specifically? Absolutely nothing. And that's why this particular lesson is all about the algebra and rearranging equations, because general form does nothing. So we always want to take it to slope-intercept form, because slope-intercept form gives us important information. And this lesson is all about taking this form to slope-intercept. Now, a couple things that are important first about what general form is. Well, general form is telling you A, B, and C are all values. A, B, and C are values, numbers. Not always, as nice as it would be, not always whole numbers, but they're numbers. So here we have an x term, here we possibly have a y term, and this would be a constant, a number by itself. So that's the first thing. In order to have general form, what is important? As much as this might be given initially with fractions, what's essential is that A, B, and C are written as integers, whole numbers. So we might be given a question that isn't where A, B, or C are fractions. We need to make sure that A, B, and C are written as whole numbers. We're going to have to manipulate it sometimes. The AX term must be a positive term. We have to make sure this AX is always positive. If it's negative, we need to arrange and rearrange things. So A, B, and C have to be whole numbers. The AX term has to be positive. And the last thing is we have to have an equation that equals 0. It has to equal 0, which means everything on the same side. That's what we're looking at doing. So if I said 5x plus 3y minus 7 equals 0, is that general form? A, B, and C are integers. Yes. The AX term is positive. Yes. And everything's on one side, so it equals 0. This is an example of general form. If I had 4y minus 7x plus 2/3 equal to 0, why is that not general form? Well, a couple different things. First of all, our AX term is negative. If I wrote this with the ax out front, it would be a negative 7x plus the 4y plus the 2/3 equal to 0. So as soon as I see that that's negative, it is not general form. The fact that our constant is a fraction tells us it is not general form. So that's what we're going to have to do today. We're going to be looking at situations, and basically general form, there's nothing new about creating equation. This is just about what we already know and then doing algebra to put it into the form we want. So let's take a look. Example 1 says to convert into general form. So what's wrong with this equation? Well, a couple different things. The order I always look at is I want to eliminate fractions first. We have a fraction we need to get rid of. The second thing, our ax needs to be positive. So the x term needs to be positive and everything on the same side. So those are the three things that I look at. To start with, we have a fraction. Last lesson, we looked at algebra to get rid of fractions. How can I get rid of fractions? Multiply the entire equation by the common denominator. And the common denominator here is just a 3. So I need to multiply both sides, all terms, by 3. This leaves us with 3y equal to negative 2/3 x times the 3/1 plus 6 times 3. Each part is getting multiplied by the 3. 3y here, cancel. That's the whole great point of doing this. 3 and 3 cancel by 3, leave me with the 1 and a 1. So I'm left with negative 2x. Denominator of 1, which means it's disappeared, plus 18. So I've gotten rid of my fractions. That's a good thing. But now I need to get my x term to be positive. Right now, my x term is negative. How do I make it positive? Well, I move it to the other side. So that means if my negative 2x moves to the left side, it becomes a 2x. That's a good thing. I now have a positive x term. But I need everything on the same side, so if I'm moving my x term to the left, everything needs to be on the left. Well, 3y is already there, so I have plus 3y. But my 18 needs to move over as well. And an 18 that moves to the other side becomes a negative 18. And if everything's removed from the right side, it will equal 0. So we now have no fractions. We have an ax that's positive, and all the terms are on the same side equal to 0. There's the general form. Pause the video, give B a try, see what you come up with. So in this case, we have fractions. Need to get rid of fractions. Denominator 3 and 2, what's my common denominator? 6. I need to multiply every part, both sides of the equation, by 6 to maintain balance. So we have 6 times y. We have 4/3 x times 6, which I'll look at as over 1, plus 3/2 times 6 over 1. Everything gets multiplied by 6. So we have 6y equals 3 and 6 cancel by 3, leave me with a 1 and a 2. 4x times 2 is an 8x. Plus 2 and 6 will cancel by 2, leaves me with a 3 and a 1. 3 times 3 is 9 over 1, which is a 9. My fractions are gone. I now have 6y equals 8x plus 9. There's step 1. Step 2, my x has to be positive. I have an 8x there. I like a positive 8x. I'm going to leave it there, which means everything on the same side, we have to bring the 6y over. So our 8x stayed there as an 8x. The 6y comes over, and when I change sides, it becomes a negative 6y. And my 9 has stayed on the same side. And all of that's on the same side, so it will equal 0. That's what this particular lesson's about, is manipulating. We don't create general form from information. We create general form by manipulating what we have, or creating the general form by what we have. Number 2, we want to convert into slope-intercept form, because slope-intercept form is, as I've said, the most important form. Slope-intercept. Y equals mx plus b. Y is isolated. That's what it's about. So here, first of all, my question is, do we even have proper general form? Well, we have no fractions. This x, we could say, has a coefficient of 1, so we have no fractions. The x term is positive, and everything's on one side. So that's a great example of general form. But general form doesn't tell me anything. I want it in slope-intercept form. Isolate the y. So if I want to isolate y, first thing I see, I have a negative 4y. I need a positive y, so let's move it over here. I still want my x to be away from my y. I still have x plus 2, but the negative 4y going over becomes a positive 4y. Divide by 4 to get rid of the 4, so y is isolated. At this point, what do I get left with? Well, my y is now by itself. I can write it over on the left or the right. Here, though, x over 4, remember, it's like there's a 1 up top. So that's a 1/4 x plus 2 over 4. Leave it as a fraction, 1/2. There's slope-intercept form. General form, it's a mathematical form that's very popular, doesn't tell us a lot, but we change it to slope-intercept. Now we know slope, we know our y-intercept. It's more useful than just the general form. Taking a look at B, same thing, make slope-intercept form. Well, in this case, first of all, do we have, not that it matters, it just wants slope-intercept, but would we say that this is a good general form? There's no fractions, but our x term is negative. It doesn't ask us to do it, but what would we do to make this a proper general form? Well, negative 2x would need to go to the other side to become a positive 2x. But everything has to be on the same side, so my 3y would be over as a negative 3y now. My negative 12 would be moved over to be a positive 12. There's the general form in true general form fashion. I know the question didn't ask for that, but I was just reviewing the concept. So we do need slope-intercept form, though. What does that mean? Y needs to be isolated. Do I like my 3y right now? I do, because it's positive. So I want to leave that, and I do want to move things to the other side. So I have positive 3y equal to the negative 2x has become a 2x on the other side. My negative 12 has become a positive 12 on the other side. And slope-intercept requires us to divide to get the y by itself. We now have a 2/3 x plus 4. Slope-intercept, what does that give us? It gives us the y-intercept. It gives us the slope. We could now graph that. Whereas our initial form, which is almost general form, there's really nothing we could do with that. It doesn't tell us any specific information. But rearranging algebraically, we could now graph that fairly easily. Intercepts at 4, and we move a slope of 2, 3. Up 2, 3 to the right. Up 2, 3 to the right. So we can see that there's a quick sketch of that equation. But this equation doesn't help me to get there, but my slope-intercept form does. And that's why it's so important. Page 36, number 3. We want to convert that into general form and slope-intercept form. Well, what do we have? This, hopefully you recognize. Y minus y1 equals m times x minus x1. We have point-slope form there. Slope-point form, whichever you want to refer to it as. Real quick review. What's our slope? Well, the slope is 3/2 because it's right there. What's the point that that line goes through? Well, our x point, remember, x minus x1. So our x1 is 3, and y plus 4 means our y minus was a -4. Change. So this equation, just to review, tells us we have a slope of 3/2, and we're passing through the point 3, -4. But we want to put it in two other forms, general form and slope-intercept form. Well, in this case, it depends on what you want to do as to which is the better one to do first. I'm not sure one is better than the other. They're kind of related. What I do know is both cases, I need to get rid of these brackets because I don't want the fraction and I don't want the brackets for slope-intercept. So what did we do? Special case, 2 distributes on the other side, 3 distributes to what's beside it. So 2 distributing to y plus 4 becomes 2y plus 8 equal to 3x minus 9. So there's our first step. Now at this point, well, we see there's no fractions. For me, I think general form makes sense right now. General form, no fractions. What else is important? A positive x term, which we have. So I like the 3x being there. What does that mean? 2y has to go over to become a -2y. The 8's going to go over and become a -8. So -9 and a -8 is a -17. And there's our general form. Well, we need slope-intercept as well. So either of these will work. I like this because if I have 2y plus 8 equals 3x minus 9, which is what I did to get rid of this first step, I just need to get the y by itself. Subtract 8. I have 2y equal to 3x minus 17, and now divide by 2. Y equals 3/2 x minus 17/2. So this gives us all three forms. Slope-point form, general form, slope-intercept. All three of those equations represent the same line, but are just different forms of it. Page 37. A couple more examples. I'd like you try A and B. See if you can manipulate these a little bit because we want the equations in general form. So see what you can come up with. Pause the video and turn it back on when you want to do it together. All right, so we're looking at these cases where we want to finish in general form So that's where we have to end up. But general form isn't a form that gets created from information. So we have to figure out which form can we create first before we go to general. Well, what are we given here? We're given a slope of 2 over 3, and we're given the point that it passes through as negative 1, 3. Well, if I'm given a slope and a point, well, that's slope point form. So y minus y1, which is 3, equals slope times x minus x1, which is x minus negative 1, change, x plus 1. There's the equation we can create from the given information. We can't always create exactly what we want right off the bat. So at this point, based on what I've been given, I can create slope point form. Now I create general. What does that mean? Get rid of fractions. So distribute the 3 here, distribute the 2 there. 3y minus 9, because the 3 is distributing by both of those, equals 2x plus 2. What else do I need in order to come up with general form? A positive x term. There it is. So everything needs to move to that side. So we're going to be left with 0 equal to 2x stays where it is. 3y goes over to be a negative 3y. Negative 9 goes over to be a positive 9. And the 2 plus 9 leaves us with 11. There's the general form for the information that's given. But we couldn't start with the general form because the general form isn't created from information. It's created by manipulating other forms. So B, let's take a look at that. Line has a slope of negative 1, 4 and passes through the point negative 4, negative 2. Well, that case, what was given? We're given a slope of negative 1, 4, and we're given the point negative 4, negative 2. So given a slope and a point, well, we can create slope point form. Y minus y1, which is a negative 2, subtract the negative is positive 2, equals the slope, negative 1/4, times x minus x1, but it's x minus negative 4, which just becomes x plus 4. And now we need general form. So again, 4 distributes to both values, and the negative 1 distributes to both values. Now we want general form. X needs to go over to the left to become a positive. Positive 1x or just x. Just x is a more simplified way of writing that. We still have the 4y on that side, which will stay. The negative 4 comes over by becoming a positive 4, and that leaves 4 and 8, which is 12. And everything's on one side, so it equals 0. Manipulating what we know to create the general form. Example 5b. Give that one a try. Pause the video, give it a try, see what you come up with. So for B, again, we want general form. But our form has to be perpendicular to this line. And it has to pass through this point. So we need to create something that has a slope we're not sure of yet. We know the slope is perpendicular to that, but we know it has to pass through the point 2, negative 3. So before I can do slope, I need to look at what I've been given, which was 6x minus 4y minus 12 equal to 0. So I need to come up with the slope for what's been given. How can I come up with slope? Well, I've been given general form, but that doesn't help me. I need to isolate the y. 4y goes over to be a positive 4y. I still have 6x minus 12. I need to divide by 4 to get y by itself. 6 over 4 just simplifies. I can reduce that to 3/2 x. 12 divided by 4 is subtract 3, and the y is isolated. My initial given general form in slope-intercept form is helpful because I now know my slope is 3 over 2. That's going to help me with my slope and what I want to create. But I want an equation that's perpendicular. So again, if my slope is 3 over 2 here, I need negative 2 over 3 because it's perpendicular. From there, I have a slope and a point, so I can create slope point form. Slope, negative 2 over 3. My point 2, negative 3, x minus x1, y minus y1. But now I need to make sure I go to general form. General form, special case, do a little distributing. 3y plus 9 equals negative 2x plus 4. 2x needs to be positive, so I move it over. I still have the 3y there, which is good. And my 4 goes over to become a negative 4. 9 and negative 4 is a positive 5. And that equals 0. There's the general form. Lots of little pieces that go together. That's what this, we started the unit just learning about all the little pieces. Now you have to bring that all together. Page 38, last example. Finding x and y intercepts. This is just kind of an interesting one because x and y intercepts, if we have general form, I can still get x and y intercepts from general form. It's not a problem. What's important about x-intercepts? X-intercepts is where we hit the x-axis, which means y is 0. So I just need to, because I have the general form, I can do that. 2 times x minus 3 times y, but we now know that y is supposed to be 0 in this case. Subtract 6 equals 0. So we end up with 3 times 0 is 0. That just kind of disappears. So we have 2x minus 6 equals 0. Add 6 to both sides. 2x equals 6. Divide by 2. And x equals 3. So my x-intercept is 3, 0. I can get it from general form. It's not a problem. Y-intercepts, same kind of idea, but our x is 0, because if we hit the y-axis, our x value is 0 because we haven't moved left or right. So it's the same idea. But now 2 times x is going to be 2 times 0, minus 3y minus 6 equals 0. So in general form, x and y intercepts will work the same. 2 times 0 is just nothing. So I want to add 6. So negative 3y equals 6. Divide by negative 3, y is equal to negative 2. So when x is 0, y is negative 2, there's x and y intercepts given general form. Last little bit to this is the idea that when we have an equation, 2x minus 3y minus 6 equals 0. The question is point 15.8 on this line? Well, if 15.8 were on this line, this x and y value could go in for x and y and balance it. It would work. That's the whole point of all these equations, all forms. We have x and y's, but if I pick a point and plug in for x and y, it should work. If the equation's balanced, then the point works for that equation. So in this case, it would be 2 times 15 minus 3 times 8 minus 6 equals 0. I hope by putting an x value of 15 and a y value of 8, I get a left side equal to right side. 30 minus 24 minus 6. 30 minus 24 is 6. 6 minus 6 gives us a 0, and that equals the 0 over there. So in this case, left side equals the right side. So 15 to 8 absolutely is on that line. Well, same can kind of be true for this question here. If I have negative 12y, so if my x is negative 12 and it is on the line, what's the y value? Well, that's just doing the algebra there. We just have to figure out for that equation. And the equation was 2x minus 3y minus 6 equals 0. Well, we're now saying x is negative 12. Subtract 3. We don't know what y is yet, so we want to solve for y. When x is negative 12, we should be able to figure out what y is. Just like we said, if x was 0, we could figure out the y-intercept. Well, if x is negative 12, we can figure out the y. Negative 24 minus 3y minus 6 equals 0. How are you going to solve for y? Combine like terms. Negative 3y minus 30 equals 0. Add 30. Negative 3y equals 30. Divide both sides by negative 3. So y is negative 10. So what do we know? We know that when x was negative 12, our y is negative 10. Because those are the points that work in the equation. So general form, all kinds of things we can do with it. Different ways it can be utilized. The problem is it's not practical to create it from a bunch of information, but we can create it from finished equations. Little different, only way to get good is practice. There's your assignment, practice it, and of course, as always, have fun.